Be quick. This meeting is being recorded. So traditionally, ETL solutions involve pulling from your source systems using a replication tool that requires a decent amount of manual labor and a lot of different drivers, landing that in a staging area. Some people in the modern data stack have suggested that this staging area is a new development. I've seen it in every data warehouse I've ever worked on, so I don't necessarily buy that concept. Transforming it into a dimensional model, traditionally a Kimball model, which you land back into a database, usually the same platform, which also is, traditional. And then you put it into a semantic layer and you surface it with a BI tool. This is sort of traditional ETL solution. There's a bunch of differences with the sort of quote modern ETL solution, even though it looks pretty similar. One is that the replication is automated. You generally don't need a lot of drivers unless you're using much older source systems. You're supposed to be able to hit a few buttons and replicate, at least if you're coming out of cloud native data sources. And then you have these data warehouse databases that are much faster, right? They have a lot more horsepower. They're auto scaling, they're auto indexing, and they use column store indexes, so they can enable a bunch of things that weren't really possible before. And I'll go through a quick list of those. And then, because replication is basically done by itself, and because of some of the speed of these databases, modeling is simpler and takes less effort, or at least that's the claim. And so you'll have a transformation tool and then a modeling tool, which are a replication tool and then a transformation tool. And then you land back in the data warehouse and surface with the BI tool. So the assertions that I have heard repeatedly from the folks who promote the modern data stack are 5, and I will recite them for you, and then we'll walk through them sort of one at a time after we get a little bit of a sense as to the experience of our panelists with the modern data stack. So assertion number 1, replicating data into the ODS/landing area can be automated, including schema drift, right? So if your source system changes, it still works, it still replicates. Assertion number 2, integer foreign keys, which is a central part of the Kimball data warehouse development strategy, are unnecessary because the faster databases like Snowflake, Redshift, BigQuery, et cetera, can handle using hashes of source system keys in relationships and remain performant. This means that there are seldom any lookups required during nightly loads, speeding up ETL and making it safe to truncate and reload any table at any time without affecting the other tables. Assertion number 3, many dimension tables and even some fact tables don't need to be run through nightly transformations from the ODS to the data warehouse, but simply stored as views or instantiated views and calculated at runtime, enabling faster development, more real-time processing, and the participation of analysts in the ETL development process. Assertion number 4, ETL managed as code using Git repositories for source control is much faster, more reliable, and easier to develop. Final assertion number 5, you do not need a separate database to serve as your OLAP semantic layer, but the same database used to store your ODS and process ETL can also serve as your OLAP semantic layer. So those are the assertions we're going to go through. Are there any other, before we do, is there any other assertions that people in the modern data stack world make that are like central to the benefit of this stack from your point of view?
I think the one thing that I found is like, it might be embedded in some of those assertions, but there's a huge amount of parallel processing. Run all of your dimensions at once, and that's okay. That's a great benefit to me.
That's a good one. We will get to that at the end if we have time. Any others?
I think some people are pushing the idea that any sort of data modeling is dead as part of this stack. So the idea that you would do OBAT modeling, one big table, if you will, and the idea that teaching things like dimensional modeling is actually harmful to our industry. So again, all these are assertions. We can talk about them each individually, but that's another one that we hear quite often, and especially if you lurk in the DBT channels, that is one that is a common assertion. There's actually been a whole book that's been written by I think he's the CEO of Chartio, Cloud, what is it called? Evan might remember, Cloud Data Warehousing or Cloud Data Management. I think it's called Cloud Data Management, which is a book that's hosted in GitHub, which is a fascinating concept to me. I love it. It's almost like Wikipedia taken to the extreme. But that's one that you'll hear too. That's another good assertion to talk about.
Thank you. I will take yours, Turner, and stick it under my number 3 because it relates to the amount of time it takes to process your model. And I'll take that one about data modeling is unnecessary entirely and put it under the integer foreign keys are unnecessary. And we'll talk about those concepts together. All right, so before we dive into those assertions one at a time, Tony and Turner, can you give us just a brief overview of where you have used the sort of modern data stack, and whether you've used it in production or whether you've just played with it, and sort of the maximum scale you've seen it rolled out at? So Tony, you go first.
Sure, yeah. So Analytics 8 works with a lot of different tools that we would contemplate as being modern. So I want to take a step back a little bit and just say the phrase modern data stack often is propagated by the 4 tools you have mentioned here. And it's very opportunistic of them to say they are the modern stack, right? It's coming from the software vendors. So I like to just clarify a little bit. When we talk about the modern data stack, I like to think about it in terms of what modern data problem it's actually solving. So think about it in terms of the variety of data that you see today and whether or not the solutions can handle that variety. So can it take structured relational data, semi-structured data like JSON, unstructured blob-like data, so email, documents, images, chat logs, log files, whatever, right? Like you all said, right, the ability to separate storage and compute for cost optimization is important, auto scaling, all those things, like the whole FinOps industry and managing your costs. So you're spending more money on analysis rather than on operations. Obviously, data volume comes into play for that. Are things performant? Do they scale? And then really looking at it from a technology perspective in terms of best of breed, are you vendor locked or can you take advantage of new technology as it becomes available and new advancements in the market, right? So when you think about data ingestion, it's not just FiveTran, but companies like QDI, HVR, FiveTran, Stitch, Airbyte. If you're looking at, you know, the actual storage layers, that could be any one of the cloud database platforms, Snowflake, Redshift, Google BigQuery, Databricks in some scenarios, Azure Synapse, right? Lots of different options, or open source like Postgres, right? Whatever you want to look at for that. There's all kinds of tools, right? So the idea, I like to think about it in terms of like, what are the modern data problems it's solving? So Analytics 8 works with, I know we have one client that has what you're calling the modern data stack here, right? FiveTran, Snowflake, DBT, out to Looker, I think was the one that you mentioned in our email. But we have tons of clients that are doing any one of those combinations plus some of the others that I mentioned, right? And so we're very familiar with this. We have lots of implementations in production for this. The scale, I asked the consultant who is on it. I want to say it's a terabyte scale right now that we're pushing through, but I don't want to be held to that. But we're talking about you know, hundreds of millions of rows going through this in what you're describing, right? So we've seen this live in production. We see it work. It does work for certain clients, and there's other clients where it's not the best option. So yeah, is that what you're looking for, Jeremiah? Or do you have anything else specific you're wanting?
You got it. Knocked it out of the park. Thank you.
Okay.
All right, Turner, your shot.
Yeah, I would agree. I mean, there's so many tools in this vast pool of the modern BI stack, and a lot of them will advertise that they can do everything. You know, look at Snowflake. Like, that product has just blown up in the market, and if you try to buy it, it's like, yeah, we'll solve all your problems. Just push a button, and that's absolutely, I don't think, true at all. You have to learn the tool, and you do have to solve those business problems, and they're very unique per organization. And I I always argue with these modern data tools that you need that big data support at that scale, or at least you need to anticipate that scale before jumping into these things. And that's where some of those on-prem tools are useful, and they still continue to be useful. So having that distinction of, yeah, they're nice and flashy and they can process tons of data, but they are, I think, only really good when you get to that data scale. To the specific stuff that I've worked on, I've worked mostly in the Microsoft space. So Azure Data Lake for a staging layer, and there's a whole process around how that should be curated. You have your raw data, transformed, zone, and then like a curated area, and that can be sent out to different places in your organization or used for different analytics purposes. But from there, that can be surfaced in different visualization tools. I've sent things to Snowflake using the data lake, and a lot of the processing for ETL for me has been through Databricks. So that was learning the kind of the Spark ecosystem, very heavy distributed computing. Same thing with Snowflake. You know, I think also there's a learning curve with understanding with big data comes big computation, and you need multiple servers underneath as your horsepower. So that distinction comes into play. But so kind of the stack I've been working with is the Azure Microsoft space using some Azure Databricks. I have used Snowflake quite a bit outside of the Azure space, but that has pretty much been my experience with some of the modern tools. And then you can get into some of the visualization stuff. I've had a bit of Tableau, Power BI, and they interact with these backend ETL tools in many different ways. Some of them are better than others. They try to generate queries and things to go back to these distributed systems, and they're not always the best. So yeah, that's kind of my background in the whole process. And I've been looking at stuff for a couple of years, and it changes every week. So
thank you. Any questions from anybody in the audience on either Tony or Turner's background?
One thing I didn't touch on, so I think a lot of the discussions today is going to be centered around DBT as well, just based on the questions you're asking. So we have several projects that are in flight right now with DBT. Our most notable one is probably iFit. So we have a webinar online you can look at for their story, but I'm happy to talk about DBT too, and the advantages of DBT and all the exciting things that we see with that as well.
Excellent. Yeah, of all these tools, DBT is the one that I am most curious about.
I have looked at the documentation for DBT, so I'm very green, and I'm also very curious. It seems like a great tool. So
sweet. I know Evan on this call has used DBT quite a bit, and what's his name? Who's working for Sub-Zero right now? They're using who is it that said that they're working for Sub-Zero?
It was Michael, right?
Mike.
Michael, yeah, they're using DBT there too. So, all right, let's dive into
This is Michael. We're using DBT.
Sweet. Let's dive into the assertions. Assertion number one, replicating the data from your source system into your ODS/landing area can be largely automated, meaning like you can do it with a few clicks and then you have to do very little maintenance. And that includes schema drift. What are your thoughts? What have been your experiences with this? Is this a valid assertion, and in what cases and to what extent?
Well, my experience has been there is quite a bit of automation in the modern stack, although I would also counter that with you could probably automate some of that with the normal ETL stack as well. We do a lot of controlling, for example, with like a metadata layer, and that's kind of your interface to tell your pipelines what to do and give it parameters. And you can code in schema drift. A little easier with some of the new tools, but I'd also argue that that already existed. Not sure your thoughts there, Tony.
Yeah. So we have clients that are using FiveTran. We have one that's using FiveTran in production right now. FiveTran is a great tool, and there are some sources that they have that handle schema drift automatically. Okay, so from my view on this, I think you need to read the fine print obviously with the vendors in terms of the actual connectors they're using, especially those that are in alpha and beta. You need to understand like every logo that's on their website. If you see alpha and beta on there, just know that you are going to be the one that's going to help them test that. And so when we talk about automated, right, that one of the benefits is you don't have to touch it. One of the downsides is if it's not working for some reason, you're relying on that company's support team to address the issue and fix it. Okay, so that's a good thing for some organizations who don't have the time or the resources to be able to, work on APIs all day for that. And certainly if you experience a lot of schema drift in sources like Salesforce, we have lots of changes, it can be a good thing to handle. Now, what they don't necessarily say is, what about all your downstream processes, right? You still have to modify when there's new things introduced or things that are removed, that you're not necessarily not going to break something, right? Still when you're changing the schema. But from an ingestion perspective, I do think that's becoming more commoditized. You had a red line for on-prem. I think a good answer for those sources are tools like QDI, formerly Attunity, right? So that's Click that has their replicate tool set, and then HVR, so high volume replicate. They're the ones you're going to want to talk to for stuff. For those two, you're going to want to talk to them for things like Oracle or SAP replication.
CData has some too, I think.
Yeah, and for the cloud stuff, right, you still have other like Airbyte, Stitch, right? They're not necessarily going to talk in terms of, automating the process of eliminating schema drift from your ETL process. They're, again, you might be it's less expensive. You might be the one that's actually helping to like debug their code if you go with something like Airbyte. But really, there are some huge benefits there. Now, like the one thing I'll say in all of this is when you're evaluating them, it's good to look at the costs, okay? Because some you're gonna pay per connector. So you're gonna say, okay, so by source, once we hook it up, we're gonna pay that much more. Others like FiveTran, you're gonna be based on monthly active rows. So monthly active rows is a unique value within a particular entity. So if you have something where you're generating new records constantly, you're going to pay for it. If you have something where that's not happening very much, you're just updating existing records, that can be a very cost-effective model for replicating data. But the idea is this is becoming largely commoditized. It's still early, I think, but the ingestion part is becoming more and more commoditized, and we need to take that seriously, right? In terms of automate what we can automate, and be serious about what we still need to be hands-on with in terms of the modern data stack. But this is a modern approach. The idea that you can automate parts of this, it's not perfect though. Okay, so don't think it's just going to solve all your problems. There's still problems. Evan has some war wounds from his time working with some of these different vendors. But to me, right, it's a huge opportunity. It's good to get in early on this stuff, especially if the cost model makes sense, because you might eliminate a lot of work that you're having to do, even with, like you're talking about, the metadata driven ingestion models from some of the legacy tool sets. So there's definitely ways, like you can create patterns to do this stuff. You don't have to buy FiveTran to do pattern-based ingestion. But FiveTran does simplify some stuff depending on your sources for sure. And the others too, HVR and QDI and all the other ones too.
Yeah, I will comment, I'll add, like, with the Azure Data Factory, which I said I have more experience with, we have this, I built this pattern-based ingestion model, and it's schemaless, and it does look at your sources and it just grabs things in as incremental as it can be into a data lake. And then from there you can do transformations. And yeah, the problem there then becomes we have very custom transformations from that point. But if something changes from the source, it just pulls it in. And we have some validations to say, oh, we've got to reload the whole thing to get the history of this. Maybe they feel that they changed or something like that. But so, and then there's a lot of parallel processing in it too. So we ingest those things pretty quickly, where maybe an on-premise or legacy system wouldn't be able to do that. Might have to loop through some things to be able to accomplish that kind of thing. So I'd say something like a data factory does benefit at that point. But copying all that data every day can be very expensive. You've got the power levels. If you bump up your power to save some time, then you're going to pay for it. So, and that's everything in the cloud basically, is if you're processing, you're paying for it. If you're storing, probably not. So
Turner, how do you, when you're jumping into a data lake, how do you keep your metadata, or do you keep your metadata? Like, do you store in Parquet files that contain the metadata, or do you take your JSON files and spit your metadata over into a separate location and then apply it back to your source data? Or how do you handle the metadata out of your source system and keep it so you don't lose it in the data lake, or do you guys do that?
So the pattern of ingestion, we can kind of manipulate, but the initial look at the source system actually gets put into an Azure SQL server, and that holds all your metadata. And then we kind of have like an interface of store procedures and kind of like power users who can, they're just developers, but we don't want them like deleting whole tables. So we've got these specific store procedures where they can control like, okay, we saw a new table come in from the source. Do we want to turn it on for ingestion? Do we want to do like, incremental loading with it, or load it in full every day? We have all sorts of options that come in, but that's Azure SQL Server. But the idea is just fine. Like if you wanted to store that stuff in another format and read it from Parquet, JSON, another transactional system, we just happen to pick a very low-powered Azure SQL Server to hold that metadata. Because it didn't change that much. So,
So if we're talking about automation, that's implying you save a certain percentage of the time, right? And consultants like me and like the two of you, have always got a temptation of walking into a client and saying, we have a system that can save whatever percentage of your ETL development time. So we're talking about a traditional replication solution without a lot of automation to one that's either built like FiveTran or HVR, or very well automated based on metadata. What percentage of the time that it used to take can you realistically save with, some of the modern approaches on replication?
Yeah, I don't have a great number on that, because the same thing, right? Like we have pattern-based replication as well, where you can build out persistent staging layers or ODS layers, whatever you want to call them, right? But the idea that you're creating patterns to do that work, to try to automate as much of that process as possible, again, is not a new idea.
Right.
But I would say the benefit is you're investing more of your time on doing the work of integrating data and doing transformation. So it's not necessarily it's you're spending less time on operational activity as opposed to trying to derive value for the business in terms of bringing disparate data together or driving insights. So yeah, it's a hard one to estimate because it depends on the client, depends on how often they have schema changes, how often they're integrating new data. But ultimately, right, you should be doing pattern-based ingestion regardless if you choose to do this like these new tools or not. If you're like one by one writing extracts for anything, like just time out, stop what you're doing and look at how to automate that with pattern-based ingestion. Either way, like that should not be something that you're spending a ton of time on one-off manual processes like that.
Yeah, I mean, that was almost word for word what I would say about it. You have that same structure in place, even with your legacy ETL tools, and that pattern's so important as you scale, like no matter what tool you're using. It's just unsustainable if you're just doing these one at a time things. And then, yeah, beyond that, I mean, I guess the time saved is how fast you can ingest some of that stuff. But in terms of building it, I didn't see too much of an improvement, especially with, I mean, they're new tools too. So sometimes you actually take a little bit longer at first than some people might be used to actually.
Yeah, where I've seen, major differences is when you're like, when you're somebody who's developing an ETL solution for your company, right? You're not a consultant doing it 100 times, you're doing it once, right? Then sometimes like having it automated by somebody else to get on the get-go can save a lot of time, because building an automated ingestion engine that's dealing with all the pattern stuff, that's a lot of upfront investment. If you're only doing it once, doesn't necessarily pay for itself.
You have to be careful though, right? Because still, if you have any issues with the sources, you're going to be dependent on the vendor to address it. And if you're syncing a lot of data and you're having to keep track of those syncing keys, they have to ingest it a certain way for loading history to make sure that you're maintaining, from a CDC perspective, that last log. So you're not touching it, okay? That's the benefit. You're not touching it. But if we're talking about calendar time saved, you have to weigh that out, right? if you want to be hands off with it, that's the value.
Any other questions on assertion number 1? Replication can be automated.
Yeah, I've got a quick question for Tony. You had talked about how FiveTran automates better on certain sources than others. Is that FiveTran doing the legwork on their side to figure out, and including with schema drift, is that FiveTran figuring it out on their side? Is it a partnership with the certain sources, or is it the sources themselves that are making that available, and FiveTran is just one of the ingestion companies that's actually using the streams appropriately?
So it's a bit of a black box, to be honest, of how they do some of the stuff. I've seen some architecture diagrams. Based on the fact that they ingest custom tables and custom fields, to me, it's like a schema on read approach. So they're saying, let's look at it. What are we getting? Okay, now let's port it over. It's not something where they're syncing with the software vendor to say, what's the schema for this client in this scenario? It's picked up on the point of actually ingesting the data.
I see.
How they do it is part of their secret sauce. So I'm not really sure. I'm guessing that they're doing some schema on read though for that.
I've talked a little bit with FiveTran and with CData on how they do that, and I know it varies by which connector you're using. Some of them, they do a certain sample of rows to determine what the schema is, and you can some of them allow you to switch how big that sample is, and some of them it's actually pulling metadata out of the source to tell you what the schema is assigned as by the source system.
That source makes it available to everybody else. It's just that FiveTran and the other one are the only two that are doing it.
Well, there's a bunch of different companies that have these kinds of tools.
Okay.
Yeah, so like Turner was saying, you can go get it yourself, but you'd have to write the code to pull that metadata and then use it in your ETL operation.
Is that one of the big selling points for FiveTran then, that they do this?
That's one of their selling points, yeah.
Data Factory too, they have like built-in connectors. It's great. You can parameterize it. So if you're like, I want to look at all my SQL servers, just cycle through them and find them on my system and pull stuff in. Yeah, they have like 90 connectors, I think, built in the Azure Data Factory. I know FiveTran is a big proponent of all that too. So
yeah, it's worth looking at outsourcing that work though. Again, from a commoditization perspective, it's only going to get better over time because it's something that you can automate, right? It's something that a machine can look at and go, okay, this is the pattern, this is how I do it. There's other parts of the stack that we're not there yet with AI. So there's things that you can automate. This is one of those things, right? Try to automate what you can automate.
All right, assertion number 2. As Tony restated it, data modeling is dead. At a minimum, there seems to be a very consistent assertion that you don't need to build integer foreign keys. You can use these tools which provide idempotence, meaning if you load the data and then you delete it and you load it again, you get the exact same data, so that you don't have to use integer foreign keys and do lookups. You can truncate and reload whenever you want to. And the reason that this is asserted to be possible is because Snowflake and other data warehouses are fast enough that they can tolerate having hashed keys of the source system keys. You don't need an integer that's a small join to be able to run at a performant layer. And some people have gone so far as to say, you know what? They're fast enough. You don't need a data model at all. Just throw all of your data into one big table and let's just run with that because Snowflake can handle it. So thoughts on that assertion? Whoever wants to go first.
Turner, you want to blow it up? I'm fine if you want to take the first crack.
yeah, well, I'm so conflicted because I come from data modeling and I'm like, I don't know about this, but there is that, yeah, there is so much processing. But I would kind of counter that with like, how much does it cost? How big is your data going to explode? Like your cardinality might get really big. I know we were looking at that article this week and it's like, yeah, your big table is going to be just absolutely massive. And it might eat up storage, it might eat up computation. But if you boost up those nodes underneath, then you're going to get your data pretty quickly, but you might cost your organization some money. The other thing I guess I'll ask, and it's because I haven't dealt with the one big table before. How do you deal with like slowly changing dimensions? Getting that history that might only be in your data warehouse. Your sources don't track that history. So if you're reloading this stuff every single day, even though it's quick, you lose that history. And I've heard people call like slowly changing dimension type 2 and above bells and whistles, but I think it's great to see how your data changed, especially from a data science perspective or even analytics. So I guess I'll ask the group here, like, am I missing how you would do that in a one big table scenario? I mean, you could stack to it, but it's saying like just trunk and reload. So I think you'd lose it, right?
That's how you're doing your ingestion, right? So if you've got effective dating on those business keys, in theory, you could then build the effective date joins as part of your idempotent transformations, right? So you'd be managing that across the transformation steps. Now you're doing that a ton, and listen to who's propagating this I don't even know what to call it, theory, idea. Yeah, if people that are paid on compute are saying this, just little red flag in the back of your head, like, okay, what's going on? But yeah, I think you're totally right. It's the slowly changing dimension issue here for type 2 and some of the others above 4, right? But the idea here is you're assuming that it's all type 1 or type 3, I guess, in some scenarios. But in terms of adding columns or just overriding in that model, or
so we're talking specifically about one big table, right? That specific portion of this assertion is what you're addressing right now, right?
No, the whole thing, right? So if you're
even whether you're
if you're hashing keys, that's just a hash of the business key. There's no other hash that's derived from that allows you to differentiate them, unless I guess you join like the effective date to it. But even then, like, gosh,
yeah, that's typically what they do. They add the date onto the hash.
Yeah. Yeah, we've seen some of that with like Data Vault, right, where you have certain methodologies in terms of how you track history. But I think Turner's right there. You have to ask about how you're managing history.
If your use case doesn't care about it, I mean, I would say absolutely. Like, there are some cases even in Kimball modeling, building on these columnar stored data sets in these modern tools, that you can kind of blow up some of the concepts from Kimball, because they were on the assertion that you're kind of using low powered hardware and you can't use multiple server nodes. So a good example, and this talks to the hash keys that you can use. When you're assigning surrogate keys on a fact, what I did, and it performed way better than cycling through the dimensions or even running them in some parallel pattern, it actually staged up all the potential surrogate updates in one big full outer join table to the hashes on the fact. And then it just in one swoop updates your surrogate key updates for your daily processing or whatever your cadence is. And it happened, the coding was very interesting. And again, like, I was like, I'm not really used to this. But it ended up processing a lot faster. So I think that concept of using the columnar storage and the power behind these tools is important, because you will get some performance boost. But to the point of one big table, this subject we're talking about here, yeah, I don't know if it always works for whatever use case you're going for.
Are you saying, Turner, that you used hashed keys as a way to look up your surrogate dimension keys?
Well, there's a table of all of the hash keys out of the fact, and then each one of those records has potential surrogate key changes from all the dimensions that would go into the fact, and then that joins back to the fact on the hash key and makes the update. And it was very performant.
So the big thing here is this is not, I understand why they're saying this from a performance perspective, okay? So if you're looking at idempotence, that's not a new concept. If you can have an idempotent data warehouse, like, yes, you should do that, but then how you're tracking history is what's important there, regardless. I think, I'm trying to think how to say this. So one of the things you have to be careful of, though, which is kind of funny, I think, I won't call out who, but one of the vendors actually stores the hash as a string, rather than a binary hash, because it's like not as performant at all. So you might take something that's like a 5-character ID and blow it up into a 32-bit hash, which makes it like 10 times slower if you keep it as a string, right? So yeah, like, you have to be really careful here if you're trying to achieve from a performance perspective what you're looking for, like hashing isn't always the best idea for that even. But I think going to the one big table, right? Part of this is propagated by the BI vendor too that you're working with. So a vendor like Looker prefers one big table typically because they have functions that allow you to do multiple levels of aggregation. Not all the BI tools have something like that, like aggregate awareness and such. But the idea is you can kind of pick what are the keys that you're aggregating on. We can have multiple levels of granularity within one big table. Okay, so you can be kind of lazy. That's great if you're using Looker, but if you're trying to reuse that across other BI tools, now you have the issue of like, now somebody has to know if I sum up on this column, it's at different levels of granularity, I might get different results back, right? That's violating some of the goals that Kimball's trying to get at in terms of making it easy for business users to use and making it performant. So I think that this has always been the debate, right? It's like, do I fully normalize or do I denormalize? And how far do I denormalize to make it easy for people? Because one big table is going to be easy for people to use if it's at the right granularity and you don't have mixed granularities in there. That's going to make life easy for people that are building stuff. But you have run into issues with reuse then too, right? So when it comes time to extend your model, can you reuse the components that are in the table or not, right? Are things, the concept of conformity that Kimball talks about as being an important thing for allowing your data warehouse to scale over time and reuse components and establish governance, right? Data quality and all those good things. And what you'll find with the one big table approach, the guy from Chartio talked about this, how they actually have an Inman model behind it. So he's really only talking about one big table from a data mart perspective. That is third normal form, fully normalized data warehouse behind that still. So if we're doing that, you're talking like, okay, you're doing the full normalization then. That's not really being intellectually honest.
You're not saving any time there.
It's like you're still doing the work of normalizing, then you're building it on top of it from a one big table perspective. If we're talking about that, that's a data mart, right? Fine. If it's purpose used for that, it's for a particular audience, I can live with that. But you know, we run into issues there in my mind in terms of, you know, creating spaghetti models in DBT where you have 17 different things doing the same thing and you have this, you know, massive pile of governance issues. And that's what we're seeing when we run into clients who have people that are not very mature with data modeling, don't really understand the concepts with data architecture. They create these spaghetti models and they have to call us to say, how do I untangle this and make it better, right? So it's a mixed bag, right? There's benefits to it, but it's not specific to cloud data warehousing, right? It's like, again, you're going to pay for the compute in doing whatever you're doing, and you're going to pay for it one way or the other. So you might benefit from having caching on one big table, where it might be less expensive. I think we'll get to that in a minute, right? Like what you're talking about having a semantic layer, but I don't think. Let me just be really clear. I do not think data modeling is dead. I think it's as alive as ever. And I think just because it's hard doesn't mean that it's bad.
When would you use, I guess here's a question. So we've been a little bit skeptical on a couple of these things. When would you see that using hash keys is a superior approach? In what situations?
When you can be idempotent. So we do this with one of our clients right now. We have part of the model that's fully idempotent, so you can drop it and reload it. You can derive the hash keys. And what's the benefit is when it comes time, if you decide like, hey, I don't like XYZ vendor, if you're using a common hash like MD5, then you can port it over to any one of the databases and use it and rebuild it wherever. It's just a hash key, right? So there's a ton of benefits to using hash keys if you can get away with it. You should do that, but be aware of the storage you're using for that. You're not making it bigger by hashing it and storing it as a string. And if you can keep it simple, right, there's total benefits to dropping and reloading and not maintaining all those mapping tables. Even if you can do things like Turner's doing, which is brilliant in terms of having more efficient ways to do lookups. If you can avoid it, like, great, but you can't always avoid it. And parts of your model, you won't be able to avoid it.
Any other questions? Yeah, go ahead.
Yeah, I was just going to say, we've also used the hash keys, SHA-1 type hashing to get comparisons going back to the slowly changing dimension argument, and it helped very much. So that is one use case for it too.
Yeah, or with change detection. So if you're actually building your ingestion,
oh yeah,
like change detection on rows. If you don't have a transactional logging against a source, like you're getting flat files, rather than comparing every column, hash it and then compare the hash, right? I think this is not new, right? Again, it's like not a new concept. And the collision rate's so low that if you use an MD5, like unless you're dealing with data where you cannot accept any collisions to any degree, then that's a good mechanism.
We are using hash bytes in our, this is Michael, in our some of our models. But one of the things we're finding is Power BI does not perform very well with large data sets of the hash. We're actually kind of looking to doing a hash to ID conversion table. So at the end step, throw an ID onto the record, and then the Power BI report would just load in the integer IDs and ignore the hashes. And we're getting some reports, we're getting better performance with that.
Are you loading it into like tabular models or anything before it's going to Power BI, or are you reading directly off of Snowflake with what you guys are doing?
Straight off Snowflake.
Oh, so you're running a direct query.
So yeah, again, making sure that you're actually using a binary hash type rather than a string. Because again, if you're using DBT, I'm sorry, I already called them out. If you're using certain products, if you're not careful, they'll store them as strings too. So that's not good.
They do, and I believe they've deprecated the ability for MD5 binary.
Yeah, and I've seen overreactions to that, right? Well, people will go, it's slow, so I'm just going to flatten everything. And it's like, that's not really the best answer necessarily. But that sounds like a good use case, though, to do the mappings out.
Yeah, we're still looking for a better solution if one's out there.
Mm-hmm.
Has anybody tried hash keys into a tabular model to see what the effect is there? I imagine it would blow up your model size, which gets real expensive. But has anybody done it?
I haven't seen that done.
Nope. The folks that are doing it are using Looker right now, and then they do one big table off of it like a data mart.
Okay. Any other questions on assertion about Dml data modeling?
So in theory, right, it's a surrogate key for you. So if you were to pre-join some of that stuff to get rid of the surrogate keys, again, from a Mart perspective, that's okay. It's acceptable. Even Ralph Kimball would not be rolling around in his retirement. If you heard that, if it's performant for the end users and it's easy for business people to use, then you can have a peace of mind in terms of what you're doing. If it violates one of those things, then you need to look at doing something different.
I'd also add in security.
Yes, that
with
is
one large
point.
Table, it's very difficult to do row and column level security.
Good point.
Yeah, it's a good point.
Even with masking, yeah, it's still tough. It's still tough.
Okay, assertion number 3. Because of the high performance, the relatively high performance of some of the modern cloud optimized data warehouse products like Snowflake, many dimension tables and even occasionally a fact table do not need to be run through nightly transformations from the operational data store to the data warehouse, but can simply be stored as views, or if you need to, as instantiated views, calculated at runtime, which enables faster development, more real-time processing, and the participation of analysts. This also relies on and can take advantage of some of the massive amount of parallel processing that's available in a tool like Snowflake. This is, I think, one of DBT's main assertions that they make. So thoughts on this one?
So with my experience in Snowflake, yes, you can query a lot of data at once, and it might be pretty fast. But if your transformation is getting kind of wild, I mean, like one of the facts with the current project I'm on, the code is massive, you know? So we would rather incrementally build on that fact, store it in Snowflake, and then users can just query that data. So, you know, the idea of having a view processing that kind of compute quickly is kind of an odd assertion for me. Now, I may have not experienced yet how you can do it so quickly, but I think there's just a point where like that's not feasible.
Yeah, again, this is just the topic of virtualization, right? So can you write a view that's performant that will return that data back in a meaningful and correct way. Again, who's propagating this? The people that like compute. DBT is not. I mean, DBT is agnostic mostly. But again, if you're not able to cache certain parts of your queries, you're going to pay for compute when you virtualize. There's a benefit in that from a real-time perspective. I think probably more realistically, you'd see this in one-off use cases too, right? Like you might be able to virtualize parts of your model to answer certain reports and stuff. You do direct query from things like Power BI, or if you're using Looker, then it's a great way to achieve near real-time reporting. And again, it requires idempotence for this mostly, because you don't want to be trying to map anything on the fly with a view. I don't even know, like this.
Yeah, I don't think that's a meaningful concept.
It's just a virtualization topic.
Yeah.
So I was going to think there's one other thing I was going to say about this. Just generally, right? The idea that you don't necessarily have to model all of your data, right? Because almost nobody has the time to model all of their data. When you create we call it a persistent staging layer because ODS is a dirty word to a lot of companies. It's the same thing, but you can actually mix the model. So this is where it gets really interesting with DBT, right? Because it's common table expressions. You're writing views effectively. You could model a new source in using this method with a data warehouse, if you have a strong business key to do that. So you could virtualize parts of your model and not others. Again, it's based on the business use case. There's a reason why this is valuable, though. You should look at this because it's easier to maintain too at times. But to Turner's point, the code can get very hairy very quickly, and you can create a spaghetti model here that ends up being harder to maintain if you're not careful. But we saw this with like Data Vault too, and Data Vault was starting to pick up some steam with Snowflake and other tool sets too, where even Data Vault, right, recommends having a business vault on top that's persisting some of those elements so that you're not having to do complex transformations and all those views on top of it. So
yeah, I think what I heard from Jason at Sub-Zero last time we talked about this is that DBT recommends that you start with a view, right? So when you're first building out your data model, if it's small enough, you start with the view and see if you can get enough performance out of that you can live with it for at least a while. And then once the performance is no longer acceptable, then you might instantiate that view, where you'll set that view down and you'll leave it there for however long. And then when performance is no longer acceptable, then you'll start exploring incremental loads. So they suggest like starting and progressing to more systematic forms of dealing with stuff as you have to. And I think this is all predicated on the assumption, which a lot of people have come around to believe, and I'd be interested in your thoughts on this too, that compute is almost always cheaper than dev time nowadays. Dev time is your most expensive resource. So if you can substitute compute for dev time, you should do it.
I would agree with that. We have Sub-Zero by default, everything is a view. And during our development with it in testing, sometimes we'll hit a performance issue and we'll determine which of the 3 or 4 model layers the performance it is in, and then we'll tablize it. So we can go from view and convert that one to a table. If we have to go to an incremental, which is the slowest one, we can also do that. But yes, I was amazed at the pure raw performance of a query coming back in like 9 seconds that it shouldn't. A SQL query, that's a 23-minute run, and it was coming back in 9 seconds. It's like I couldn't believe you could actually do that. So I was really blown away by some of the performance issues. And these queries, the views are ugly. I mean, just because our data's model is ugly, but each going through, it's view on a view on a view on a view. And you get all the way from raw, conformed, EW up to reporting. You got 4 levels there that you can mess things up in. And most of the time it works. But when it doesn't, DBT gives you the option to get the performance in there. You can move it. We even have some things that are near real time. We're in a 1-minute update cycle on some of our production line support. So they have real-time dashboards running. So that was an interesting project we just finished with that too.
Yeah, I want to ask the 9-second query versus the 23-minute. What was the data volume on that?
Big. That was why it was 23 minutes. It was several 100 million rows that were very wide and like 20 table join.
Okay. Yeah, so I will say like Snowflake, absolutely, as an example of one tool, will pull back based on how powerful your warehouse is that you're running. Can pull back some pretty impressive runtimes, especially if you make the tables underneath performant. You can partition that data because underneath it's all these little files. And if you order your data and partition it properly, then it's kind of like indexing. The system can go find those pieces of data a lot faster. And Snowflake can pull stuff really quickly, very impressively sometimes. And then kind of back to the point of views, and I think this was brought up in the insertion, but under a different name, they have this concept of a materialized view. It's like a table. It's automatically generated and kind of stored when the underlying data is changed. So they, some of those modern tools have features like that that can help you, although it's limited. Like you can't add really complicated joins in a materialized view. And it's going to cost you every time you change your data. So you have to kind of like weigh that too, because it's computing that. Yeah, it can be impressive for sure.
We have a customer that has ratcheted up their virtual warehouses to the highest level for that purpose of saving money on consulting dollars too, because we get more stuff done. So yes, I've seen somebody do that. The math does work under certain scenarios for that. So yeah, it's valid. And here's the thing, right? Like it covers over a lot of sins of poor modeling. That's one of the reasons why people like it, because you can just jam it through. Yeah, I mean, it's expensive, but the cost of data engineering resources these days is such that it might be worth it. So you got to do the math on it for sure.
Something that surprised us when we did some performance testing on warehouse size is we were only on 1 or 2. We're not on the higher levels. We tried moving up and our performance didn't change. And in some cases it went down just due to the instantiation time. What helps the most is being able to parallelize. So if you have a job that you have, if it's set up so one job has to run at a time, you're not going to go fast. But if with the multiple views where it can sub-parse it out and do, especially with all the tables, and go work on a portion at a time and bring it all back in, Snowflake is fantastic for doing that. So that's where you can really, write small pieces, not huge joins, but lots of little views, and it will bring them all back for you and do it very quickly. I wish I bought stock in Snowflake.
You're
You
not
still
the
have a
only
chance to keep an eye on DBT. That's a fast-growing company, no doubt, with Fishtown.
Are they public?
No, I'm saying just keep an eye on them.
Yes. Yeah.
If you run a venture capital firm, yeah, now's the time,
I will say to that point, I mean, and I kind of wanted to bring this up earlier, and it's kind of out of scope to the assertion, but we are talking about features of Snowflake. So Snowflake is a whole platform, right? So they even have their own ETL tools. If you wanted to stage different sequence of events and tasks to call different things and just do everything in Snowflake, you could do that. You could do everything in Databricks. You could do everything in Azure Synapse, but these certain phases of how you're loading kind of work better in different tools, and people have different experiences. But to your point, Michael, like doing everything in Snowflake can absolutely work. And I guess that's any tool. If they advertise different features, when to use them. But yeah, some of these new platforms are like you do everything.
Actually, right now we have multiple. Snowflake's the database. DBT is what we're moving over for the ETL tools. We're using Talon for some of that, trying to get off the major ETL. But we're using Talon for raw data, getting into raw. So wherever the data source is into raw, because Talon's pretty good for that. Yeah, we also have I think Click Replicate. So we have multiple ways of getting data into raw. And the interesting thing, which I was really blown away with, is most of our data resides in raw, and the data never moves beyond raw layer. So when we do the query reporting, we're looking at data in raw, and that I couldn't comprehend that when I first thought about that. But that one I had to think about for a while, but it works. So don't dismiss it.
Yeah, for sure.
My
Let's,
job in 2 years.
let's move. Well, there's still other parts of your job, I hope. All right. So assertion number 4, ETL that is written and managed as code that does not include a graphical user interface is superior to graphical user interface driven ETL, in part because it can be managed in Git, and in part because it's just more intuitive to write the code, because there's always something buried in a submenu of a submenu in your graphical user interface that you won't know you're supposed to check, and it'll drive you crazy for a month. So code-driven ETL is, the assertion is code-driven ETL is superior to graphical user interface-driven ETL.
So as somebody who's technical, I like this. It's funny to me how some things has moved towards trying to have more graphical, and other things like this have gone so far the other direction. Like, no, forget it. Like, everything's code. So it's funny. I think another benefit to this is that you allow for multiple developers to work on different parts of the code without worrying about like having collisions in your repository and all that stuff. And some of the graphical user interfaces where you only have one person that can work on it at a time, and you go, my goodness, that is not good. So that's a huge benefit. And then the other thing I would say, right, is like just being aware, if you have an organization that has low code principles, like this is going to violate those principles. But you got to ask yourself, right, if you're using a tool like Matillion or Azure Data Factory, your developers are probably writing a lot of code still and putting it into the custom little drop-ins, because you can typically make it go faster by doing that. So again, this is not a new thing. People have been staging lots of code inside of like SSIS and Azure Data Factory. We're not using the drag and drops for some time, but yeah, it's a strange trend, and it's one for this seems like mostly a technical audience. It's one that your leaders might push back on, right? Because they might think this is going to take more time. You know, the GUIs are supposed to save time, and it takes some education to be like, we're still writing code. Like, there's no way we're not writing code. Okay, let's just move on from that. Transformation steps are still not at a point where we can leverage a ton of automation to make decisions, to like inject business logic into data to turn it into information, right? We're still a ways away from that. That's probably the last thing that will happen on the AI track. So that's my take on it, at least.
Yeah, I mean, someone who comes from Azure Data Factory, I was going to say, like, what about both? Because you can integrate Azure Data Factory with DevOps, and then on the back end, it's all JSON, and they're just rules applied to it. And yeah, to your point, like, I'm always, like, even though I'm dragging some boxes around, I'm coding. I have to call specific business logic. I have to dynamically put in variables and parameters to these pipelines so that my stuff builds. I will say the graphical interface is really nice when I'm explaining some things as a consultant to people who won't understand the code. I can say, this is visually how this thing works and how it looks, and here's some runtimes and like all the nice green checkboxes and everything. So from documentation and, you know, transferability to like the business, I would say the graphical user interface is very useful. But yeah, you're coding anyway. So
yeah. And DBT has lineage graphs that are pretty sweet to be able to do that still.
Yeah,
they do. But it doesn't turn green when it's running.
Right. Where are the colors?
It's always running. It's just a view. That's fine. Yeah.
I know Apache Airflow, if you've ever used Apache Airflow, there's heavy code with it, but like the graphical interface is nice to see what ran. However, you do have to name things correctly to see what happened if you don't want to dig into the code. So yeah, that's an interesting question.
I would also say this is where we have the problem, right? Where there's no framework. It's literally do whatever you want. And I'm fighting spaghetti constantly. Because it's very easy just to add another CTE in and just start a new data pipeline, right? So I like this. I like this trend. I think it's good. I convinced my friend. I said, look, this is good. This is a good thing. It's not a bad thing. Don't think this is a regression. Like, we're moving forward still in this. because I worked with tools where, oh my gosh, you just want to see what the heck it's doing because it's just not behaving like you're expecting it. You can't see it. You got to like try to figure out and read the tea leaves on what's happening. So this is a good thing, but it takes some convincing of leadership. Yeah.
I would say this is where software development, and I would actually argue that a lot of data engineering and data warehousing needs to work more with management and with the business to set those software development policies. They understand that there is a lot of code being written. It's not just a button you push. And to avoid having spaghetti code, because I don't think there's a tool that will just protect you from doing whatever you want with it. How could it? And that's how it's sold. Like, you can do what you want. So you need to have those rules in place and those policies from an organizational perspective, from your software development team, to protect it against that kind of thing in any tool. And it's like the last thing people think about for some reason. It always ends up like this one little thing was built to solve this one little case and no one documented it, and what's it doing? That guy left. So
pop quiz, if somebody says, hey, is it okay for me to approve my own pull request? What's the right answer?
No.
Well, okay, this is a good point though. So this also does enable certain levels of CI/CD. We don't have to push a full repository. You can push just components too. So there's lots of good reasons why this is a good move. It's like you said, Turner, it's perfect. It's going towards the software development lifecycle. We're trying to act like adults now. We're going to be grown-ups. So it's good. And my teams like love it. They just eat it up. People that have to be hands-on with DBT, just like Evan, I'm sure he's going to be quiet on this, but he is the biggest fanboy of DBT, and has other tool sets that are more graphical and has asked for DBT. So yeah, it's one that techie people like.
Yeah, I will say, coming from like kind of the legacy data space and not treating it like this big software package with different pieces that are being developed and integrating it with a DevOps or a GitHub, it was very tough to develop against that with multiple people and version control, or like moving to using Azure DevOps and attaching your features to stories and like seeing every little code change and doing pull requests and collaboration, just like a big software package. It's more nuanced. I absolutely like it too. It's much better for governance and not pulling your hair out.
I'm not going to take that as a shot.
Oh, sorry.
I could just
I
add
know how
that-
many wars I've been through, right? It's like, oh my gosh.
Yeah.
I can just add that it's nice that we're migrating less of our code to be on Talend and more on DBT.
All right, we're getting close on time. So assertion number 5. This one is the one that I had the most trouble with, especially in a Microsoft context. Assertion number 5, you do not need a separate database to serve as your OLAP semantic layer, but the same database used to store your ODS and process ETL can also serve as your OLAP semantic layer. Responses to that one?
Okay, I guess I'll give an example. I'll go back to Snowflake. So if you were to build all of that inside Snowflake, you have all of your layers in it, you can absolutely do that. You can even add indexes in Snowflake, even though it doesn't enforce them. What it does enforce it on is the semantic layer when like a Power BI tool connects to it, and it'll create that layer out of those definitions that you give it. Unfortunately, Snowflake, like a tool like Snowflake, won't enforce it for you, so you have to wait to get it into your reporting tool for it to maybe break on you. But that kind of thing is possible in my experience. But like if you go back to the SQL Server days, like you were saying, Jeremiah, it's a totally different engine. That semantic layer, and Azure has analysis services. That's the cloud version of SQL Server analysis service. Totally different engine underneath it, and because you're kind of looking at the data a lot differently than a transactional system. So that is a very interesting assertion for sure, and I'm not sure if I totally agree with it. I think you can like mock it up in some of the new tools, but that's my experience. Maybe I missed something.
Where we saw this be successful was with Looker, because you can build the definition files in DBT, and then you can migrate them over into Looker. And Looker's got a pretty freaking sweet deal in terms of how it handles the semantic layer. that's one worth looking at. If you have not looked at Looker, you should look at Looker. I do not mean to say the pun there. But again, right, you want to think about it from a cost perspective. You might save money by loading data into like tabular services or analysis services, right? Where if you're in the Azure stack, where you go, if we can load it into the BI tool and not have to run compute all day, it's a way to make Snowflake a lot cheaper, right? If you can deal with the batch loading out. So you have to make sure your strategy of how you optimize your cost distribution is thought through and managed. So we're seeing, I have a client that's using Looker and DBT and Snowflake, and they're able to do this. And it's very cool. And we didn't even talk about like the automated testing and
right, we didn't. You're right.
documentation, right? Like there's all kinds of benefits to this, but I see this as a yes, but right. You have to, there's trade-offs, always trade-offs.
Right. So Looker's a tool that's like sold as, you know, you can generate effective SQL and you can run models on top of Snowflake, et cetera. I think Power BI is generally assumed that you will always bring the data into Power BI. You can run direct query, but everyone I've talked to has said it's generally not very performant. I don't know if I've heard mixed reviews on Tableau with regard to this. So it seems like it might be a little bit tool dependent on your BI tool.
You can remove the tool dependency by doing OBAT, one big table, on your on your feeds into those sources, right? That's one of the reasons why that's a good approach. There's nothing in Kimball that says you can't build a view or something, some materialized view on top of your dimensional model to make it really performant on the BI layer. That's not, you're like, again, we're not slapping Ralph in the face with that. So it's there's ways to make it fast and to make it cost optimized. But again, you're gonna have to look at each use case. That's what we found.
And do you have to go so far when you look at each use case as loading it into the tool to see how big it is and see whether it performs? Or do you feel like you can predict pretty well?
I like the eyeball test, right? Let's see if we can do direct, if it's fine. If it's a cup of coffee report, we have to walk away, get a cup of coffee and come back. Like you need to do something different. People don't have patience for that these days. I'm sure there's very formulaic ways you can do it, but ultimately, right, it's like, sorry, I forget his name now. It's like what Michael was saying, right? Like just ratcheting up the warehouses doesn't always solve the problem either. So, you know, I'm sure there's really quantitative ways to do it. I think we just kind of eyeball it sometimes though, just because frankly, it's faster.
Yeah, from the Tableau perspective, I know grabbing things out of Snowflake and loading a data set, you know, based on their cadence of reporting, which the project I'm on currently that uses Tableau, it's a daily, we process our daily batch because we get all the sale data from the day before, and they generate a kind of data set file for Tableau, and it's much faster than direct query to Snowflake. Because yeah, Tableau generates some pretty wild queries and ups the costs and all sorts of stuff. The end users are complaining sometimes about slowness. So we went through this whole data set file generation with Tableau, and it was much better with the volume of data that we were using. But like Tony said, I mean, if it's performant with a direct query, then that will work for a while. So.
Yeah, and to Tony's point, the BI tools are starting to diverge and play with different pricing models, which is interesting. It's like a moving target. Like Microsoft is just rolling out now, you pay based on your largest model, right? So you could have 100 10 gigabyte models and you pay for 10 gigabytes worth of space. You pay for, which is a fascinating pricing model. It seems like they're all kind of like, it hasn't diverged to, just like the replication tools, they all have different pricing models. And so it's an interesting like math exercise to figure out what you're going to get.
Yeah, I have a client that's using Domo right now who just got hit with a massive price tag for loading all of their data into Domo and pre-staging, right? Because they're trying to capture costs. Like nobody wants to do any of this stuff for free, right? So if the economics work on it for a season, it's good to reevaluate and look at how you can optimize. Because yeah, it seems like the rules are moving. Yeah. That was not a fun day for that person when they found out they had to pay for data storage and they were getting, you know, a sweetheart of a deal.
The Domo is hot right now. Does anybody have any thoughts on Domo? A lot of press on Domo right now. I think that's the one. Isn't that the one that's being promoted by DBT?
I haven't seen that. I've heard Looker a lot, but I don't know about Domo. We have one client that's using Domo. The people that like it love it. But yeah. It's more popular out west, I
I
think.
think I have to learn DBT now.
So this is a good point. So I was able to go through their like online boot camp thing about an hour and a half on a Saturday. Like you can totally get your hands on it. They have sample stuff that you can do in Google BigQuery. Like it's all for free. You can test it for free. Everything's for free for that. Just try it. Like it's kind of neat, and it's good just to kind of stay up with tech. This is one that I think is going to get more and more attention as we go, and it's an easy one to just kind of poke around with and see for yourself without having to convince somebody to procure it, or without having somebody call you constantly trying to sell you it.
Yep.
Yeah, and that's not the one that's going to break your bank. It's not. I've not heard of anybody being like, "Oh, DBT, they took all our money because we ran this thing wrong," and it, they just don't price things that way.
Yeah, it's about $50 a developer if you do DBT Cloud, and I think you can host it yourself. It's neat. It's really cool.
All right. Well, we are at time. So thanks, everybody. Thank you to our panelists. This has been a great discussion, and I'll look forward to sharing it with people online.
Thanks, Jeremiah.
You guys, thank you. Thanks for having me.
Yeah, thanks a lot, guys.
Yeah, thanks, guys.